Paul's research focuses on the geological history and evolution of the moon and processes of impact and volcanism that have shaped its surface. He studies the moon largely by remote sensing, whereby composition and physical properties are determined through analysis of data returned by orbiting spacecraft and from Earth-based telescopic sensing. I have no idea what I just said. But I'm just going to ask you to look into the program, and it'll tell you a lot more about what he does. But I know he is a friend of NASA. He's a friend of research, a remarkable gentleman who will tell you a lot about the work that he's doing. Again, I'd ask you to read some of his bio that's listed here. But a good friend of mine, a good friend of space, a good friend of the moon and the things that are going on there, I'd like to introduce Dr. Paul Spudis.
Thank you very much, Glenn. I'm happy to be here today to talk a little bit about the moon. And I call my talk Lunar Space, the Next Frontier. You may wonder, since I'm sort of known as a lunar scientist and as a lunar advocate, why I've suddenly shifted gears. Well, I haven't really. The point I'm trying to make is that I think that the movement of people into space takes place in steps and stages, and Lunar Space is the next step. When we look back at the history of the space program, we've sort of had three ages of space flight. The space age we're all familiar with occurred from the 50s to the 60s, where we're racing the Russians to the moon, and that was the dominant objective, and that was one that was achieved. But at the same time, we learned in the 60s the value of space, utilitarian value, and that came from as a result of launching satellites that did things like monitor Earth resources and they created communications relays. Those kinds of things were documented and demonstrated and then basically transitioned to the private sector. So that template of the first space age kind of set the model that we've come to expect for NASA. NASA does the things that pushes the envelope that are hard, and then they move on to the next challenge. The middle age I'm calling sort of the what now age, is after we went to the moon, it wasn't clear what the next step was. The country was not ready to support a vigorous effort to go beyond the moon. So effectively we returned to Earth orbit, and we focused on trying to make access to Earth orbit routine. We didn't quite succeed in that. However, we did learn a lot as a result of the shuttle program and the station program, both of which had troubles along the way. They were questioned in terms of their value. They were questioned in terms of their mission and purpose. I think in retrospect, I see very clearly what they have taught us, and it's a great deal. But another issue that arose at the same time was, is space a place for people or machines? Do we want to send people? Why do we have a human space program? Those questions began to be asked in this age. The current age, I'm going to call the beyond LEO age, beyond low Earth orbit, and everything is in total chaos. Everything is up in the air. Where are we going? What's the purpose? And what is the value of space? What's the new value? Now, basically, I'm looking at this from the perspective of creating a long-term, permanent human presence in space. What's the problem? What's the fundamental issue? I contend that the fundamental problem is that we cannot lift out of the Earth's gravity well everything we would need to create thriving human communities in space. So what that means is we have to learn how to use what we find in space to create this capability, to create this sustainability and habitability. As long as we are limited to what we can lift out of the Earth's gravity well, we will be mass and power limited in space and therefore capability limited. So the key to breaking that, to breaking what my friend Don Pettit calls the tyranny of the rocket equation, we have to learn what to use what we find in space to create this new capability. So the current template is largely design a specialized vehicle, launch it on an expendable rocket, operate it for a bit and abandon, and then repeat that template. What we want to do is transition to a new template, a template that basically uses incremental bits to build expanding distributed systems that are capable of being maintained, of being serviced, of being upgraded with time. Fundamentally, this means that we're going to create a system to create routine access to our assets that occur in LEO and beyond. That's the template we want to move to. Now, I want to shift gears very slightly for a little bit to basically ask, what's the value of exploring? Why do we explore at all? And you may question my use of the word exploration. You may think I'm talking about utilization, but I'm not. I think exploration, I think the meaning of that term has been debased in recent years. Fundamentally, I think humans developed the exploratory urge because it conveyed an evolutionary advantage. It allowed us to predict where we might find better food, better shelter, better mates. All those things fed into the impulse to be curious, to look over the next hill, to find out new stuff. At the same time, the exploring impulse broadened the intellect and the imagination. Because people had broader and deeper imaginations, they were able to visualize possible solutions to problems that otherwise they wouldn't have been able to do. So in the long run, exploration gave us an advantage not only in survival, but also in thriving and in multiplying, because we were able to envision solutions to problems that otherwise wouldn't have occurred to us. And also, I think that the act of exploration inspires the productive and creative segments of society. We see new things, we see bizarre things, things that we couldn't have imagined, and that broadens both the knowledge base and the imagination base of humanity. Now, exploration and science are not the same. A lot of my colleagues seem to think that they are. But fundamentally, exploration is a very different activity. It's largely a curiosity-driven, curiosity-satisfying activity. It effectively is not directed. It continues in apparently random directions, but in actual fact, new discoveries lead to new avenues of inquiry. And so it has a non-directed, it has structure, but it's not directed. Now, science, on the other hand, is the process by which we explain nature. And exploration, that fundamentally enables science. By seeing new things that we're forced to devise new explanations for, you're actually creating the situation where science can advance and progress. So exploration precedes and enables science. The other thing I want to point out is I think that we've come in the last century to misunderstand the original meaning of exploration. I put this quote at the top: "Exploration without science is tourism," and it was uttered by a AA of NASA. And I marveled when I heard it, because in one fell swoop, he consigned Christopher Columbus and Balboa and just about every great explorer that had ever lived to the category of tourist. Fundamentally, the equation of exploration with science is a 20th century artificial invention. It started with the golden age of polar exploration, when Amundsen and Scott were racing to the poles. It became a nationalistic endeavor, a projection of power politics. Science was tacked on as kind of a justifying activity. But fundamentally, exploration is more important than science because it is broader and richer than science. It includes both asset creation and wealth generation. Science is fundamentally simply the answering of specific questions. And finally, exploration enables science. And I got two pictures. One is that of the HMS Endeavour, which of course is Captain Cook's journey around the Pacific. Added greatly to our scientific knowledge, but no one ever claimed the Royal Navy was interested in science per se. And the Scott Amundsen base at the South Pole, again, an enabling science asset caused by exploration. Now, why people? Why do we need to send people? Why can't we do this all with machines? Fundamentally, I think that humans bring unique capabilities to exploration. They are intuitive and they're able to adapt to changing conditions. They bring expert knowledge to bear on specific problems. They can recognize key significant details out of a myriad of confusing observations. From the billions of bits of data that our senses receive, we're able to zero in on exactly what it is to specifically answer and address the topic that we're investigating at any given time. They also combine great manual dexterity with this expert knowledge, so they're able to build and maintain complex equipment, which is very difficult for a machine to do. Robots are great. I've spent most of my life in the robotic space program. I love them. However, they are limited. They're fundamentally limited to what they're designed to do. They can only investigate questions they're specifically designed to answer. So we don't know ahead of time what the most important and pertinent questions are. The ultimate rationale for human spaceflight is fundamentally different, and it relates to species survival. And one of the big scientific benefits from Apollo was that we found out that hypervelocity impact is one of the fundamental processes responsible for not only for the creation of the planets, but for the ongoing geologic evolution of the planets. We also found that these impacts occurred throughout Earth's history and may be responsible for giant mass extinctions. Now, that's not a question of, is this going to happen? It's a question of, when is it going to happen? So the simple fact is, if you want humanity to survive, you're going to have to create multiple reservoirs of human culture. And the way to do that is to expand human civilization off the planet. I want to point out a key document that came out in about 2006 by John Marburger, who at the time was the head of OSDP and President's Science Advisor. It's a very interesting speech. It's largely overlooked, but fundamentally what he argued was that the reason we have a space program is to use space for the benefit of humanity, which I thought was a very interesting perspective. Fundamentally, he argued that we should incorporate or plan or try to incorporate the solar system into our economic sphere. So effectively, this is almost the antithesis of the classic Van Allen, Saganite scientific preserve that the space program has always been. This was saying that no, space is an endeavor that humanity is involved in for multiple purposes. Science has its place, but economic growth has its place as well. So if you look at all these policy documents, and I'm including not only this speech, but also a bunch of many books and thoughtful articles by a lot of people over many years, you see common themes that start to emerge. That fundamentally we need to have a program that we can afford and that will continue. We need to explore with humans and machines. Either one or the other is not sufficient. We need to create test beds and systems to learn how to do things in space. Fundamentally, all these things lead up to a statement of mission. And so what I'm going to call the statement of mission as far as relates to the moon is, we're going to the moon to learn the skills that we need to live and work productively on another world. So what am I talking about? Well, I think they can be broken down into three categories. You want to arrive, you want to survive, and you want to thrive. When you arrive, you create a transportation system that routinely gets you to the various places that you need to go for whatever your purposes are. To survive, you need to be able to build habitats that allow people to live on other planetary surfaces in relative safety and comfort, and to conduct productive work while they're there. But ultimately, you want to thrive. You want not only to just get up there and survive and eke through a mission by gritting your teeth and holding it in for a week, you actually want to be able to create a product that makes money. You want to export product for a profit. Effectively, you want to create an economic sphere as part of your movement into space. So what kind of space program are we talking about here? Are we talking about a conventional one, sort of like the one we've had for the last 50 years, or are we talking about something fundamentally different? Well, originally, the space program was basically an instrument of national policy. It was involved heavily in geopolitics, the race to the moon. However, we found as part of this that we had a lot of good byproduct from the space program. Byproduct that in fact created economic growth and created wealth. So despite this, despite the fact that space, quote, applications or space utilization or whatever phrase you want to use, has already documented its value many times over, in terms of a national civil space program, we seem wedded to the idea of PR stunts as goals. So right now you hear talks about human missions to asteroids or human missions to the moons of Mars. You don't hear talks about human missions to establish a resource base on the moon. I contend that to create real sustainability, to create a real lasting federal civil space program, you need to have value for the money spent. Fundamentally, space must be relevant to national scientific, economic, and security needs. And in fact, that very phrase was used in the founding documents for the Vision for Space Exploration in 2004. Now, it's a different country than it was 50 years ago. I mean, it's not the Apollo age anymore. There's a different geopolitical landscape. Effectively, we don't have the same sense of urgency. When we were racing the Russians to the moon, people put in 18-hour days, not because they were told to or because their bosses directed them, but because they wanted to. They thought they were doing something extremely important. It seems that through time, the productive segments of the agency have shrunk and the non-productive segments have grown. And what's more, that's true not only of NASA, but that's true of our entire technical industrial infrastructure. It's very hard now to get the kinds of innovation and technical expertise and know-how that was very common during the height of the Cold War. We're in a constrained budgetary environment. I'll talk a little bit more about this at the end, but the perception that NASA had a blank check is not quite true. They had to basically fight for their budget every year, just like we do now. However, the perceived political urgency was different, and so therefore it was a much easier fight, and they got key allies much more easily than people do now. And finally, I think there's a general risk aversion in this country. I've actually heard someone fairly high at NASA say safety is our first priority, which when you think about it, then that's an argument not to go anywhere. Because if safety is your first priority, then there's no reason to go anywhere. The ultimate safe mission is the one that doesn't get off the planet.